Now this is a question from prime numbers. So first I'll just solve this problem and then I'll also teach you a method to remember the prime numbers. So the question is saying there are three distinct prime numbers. Distinct means different. The prime numbers should not repeat. Three distinct prime numbers whose sum is also another prime number. What are those three prime numbers? So you can see there are infinite prime numbers. So that statement alone cannot give me the answer. So I have to check the statement 1. Their sum is less than 23. Okay. So first of all, we have to see, we already know that their sum is a prime number. Now we have to know that statements 1 says that their prime number is a prime number which is less than 23. The prime number less than 23 is 19. So let's write down all the prime numbers till 19. We have 2, 3, 5, 7, 11, 13, 17 and 19. The next prime number is 23. I'll teach you how to remember them. First of all, the first 8 prime numbers you have to by heart. Okay. So their prime number is less, their sum is less than 23 means their sum should be from any one of them, and of course the number also should be any one of them. So I'm going to say that there are three numbers. There are three numbers. When I'm adding, I'm getting some other prime number. So first I'm going to assume that let the sum be 19, because the sum is also another prime number, right? Let's assume that the sum is 19. Now if I take the value 17 and put it here, that means 17, 18, 19. I need two more numbers and it cannot repeat. So I have 2, but this place will become empty. I need the sum to be formed by 3 numbers. So this case cannot come. This cannot come. Now again, I'm still keeping 19 only. Instead of 17, I'm taking 13. 13. So 13. 19 minus 13 will be how much? 19 minus 13. You need to get a 6. See, if I had taken 3 2 times, I would have gotten a 6. I would have got this 19. But it clearly says that the numbers are distinct. So you cannot repeat. So 5, 1 is not there. 1 is not a prime number. There is no combination which you can create a 6 from this thing. So this is also not a possibility. Again, I'm still keeping 19. Now I'm taking 11. I'm gonna take 11 as the number. So that means I need to form an 8. Yes, that is possible if I have a 5 and a 3. So the first set of prime numbers which satisfy the question is 3, 5 and 11. Okay, there is no other number which can be formed from 11. Now if I put 7 over here, say I don't have to check above because we are going systematically, right? So I have to select the remaining 2 numbers only from the left side, because if for example, imagine, okay, I'll come to that. For now you can check, I'm still trying to make 19. I need to get a 12. There is no way I can make a 12 using the remaining set, so this is not possible. Now again I'm trying to make a 19. If it is 5, so I just told you that I don't have to check the numbers on the right of 5, I only have to check the numbers on the left, because if I also consider the numbers on the right, then you will see that 13 can be formed, 3 can be formed, but that we already, sorry, 3 nahi, 11 can be selected, 13 nahi, 11 can be selected and 3 can be formed. Yes, but that we already found, right? So to avoid repetition, I don't have to check right, only have to check in the left side. There is no other combination. Okay, so all the combinations of 19 are done. Now let's see if the sum can become 17. Okay, so 19 is done. Let's see if the sum can become 17. So I'll start with the highest number, that is 13. Is there any possibilities? That means I need to get another 4 more, right? 13, 14, 15, 16, 17. I need to get a 4. I cannot repeat, so 2 cannot be used. 3 and 1 is not a prime number. 3 is there, but yeah, no combination with 13. So that is done. Now instead of 13, if I put 11, then I still trying to make 17. I need to still get a 6. I cannot get a 6. 3 cannot be repeated. There is no other combination. Okay, so 11 is also not a combination. If I put 7, of course, then I have to get a 10. 5 cannot be repeated. There is no combination. and you don't have to go below, it's not gonna come. So 17 is done. Now again let me try with 13. Let me clear this thing a bit. Let me try with 13. So 19 is done, 17 is done. I'm trying to get the sum of 13 using 3 sums. So I just have to look below because 13 cannot be formed above. 11 cannot be selected because only then 2 will be there. 3 numbers cannot be used. Then 11 is done. 7. I need to form another 6. Of course, 6 cannot be formed using the remaining numbers. It's not possible. So 7 is also eliminated. If I put 5, using 3 and 2, I cannot get 13. So that option is also done. So 13 is also done. Now if we try to make the sum to be 11, 7 plus what is 11? 7 plus 4 is 11. 2, 3, 5, I cannot make a 4. So 7 could not be used. If I put 5, can I put 5? 5, then I need to make 6, 7. No, there is no possibilities. In fact, you don't even have to check below. There is no possibility. So just by using statement 1, you were able to get only one answer. Since you are getting only one answer, not more than one answer, you can exactly say that the three prime numbers are this, and the sum which we are forming is 90. So you can answer this problem using statement 1 alone. Okay. Now let's look at statement 2. One of the number is 5. See, they are saying that 3 numbers are there, 3 prime numbers. You are adding them to create another prime number. And then they are saying that one of the number is 5. The other numbers are prime. First of all, infinite prime numbers are there. So any other prime numbers can come here. And there might be some prime number which can form. There might be many infinite possibilities also. You don't even have to check. Statement 2 alone cannot be used. Okay. So since statement 1 gives us answer, we can answer the problem. The question can be answered. Of course, it can be answered by using one of the statement alone. Because we only use statement 1 and cannot be answered using the other statement alone. Yes, it cannot be answered using statement number 2. So answer will become A. Now, I'll also tell you a method to remember the prime numbers. The first prime number is still 100. Okay, this method is known as Pulu's primes. Okay, so what you have to know is that imagine if I write the numbers like 1, 2, 3 till 10, 11, 12, 13 till 20 and keep on going till 91 till 100. The first rule is that you have to eliminate the edges. 1, 10, 100 and 91 are not prime numbers. This is the rule 1. Now the second rule is that in the first 2 columns there will be 4 prime numbers each, which you have to by heart. You have to by heart this because you need to use it more actively. So it should be in your random access memory. Okay. So let's see the first 2 columns. We have the prime numbers like we have the prime numbers like 2, 3, 5, 7, 11, 13, 17 and 90. We got the first 8 prime numbers. Now to find the remaining prime numbers, we'll take some reference points. The reference points will be 30, 30, so we have 20, 30, 20, 30, 40, 40s will end at 50, so 60, 80, yeah. So these 3 points, 30, 60 and 90 are reference points. They are not prime numbers, so you have to cross it in the starting itself, or else we might easily get confused. Now, just before 30, we have 29 a prime number, and then you have to take a jump. 23 is a prime number. Just before 60, we have 59 as a prime number, then you have to take a jump. We have 53 as a prime number. Just before 90, we have 89 as a prime number, then you have to take a leap. 83 is a prime number. Again, go back to your reference points. Again, go back to this reference point. Just after 30, we have 31 as our prime number and take a leap. 37 will be a prime number. Just after 60, we have 61 as a prime number, then take a leap. 67 is a prime number. Just after 90, 91 is not a prime number. I already crossed it in the starting. 91 is not a prime number. Then take a leap. 97 will be a prime number. Okay. Now the only columns which we are missing are the columns starting with 41 and 71. Interestingly, both 41 and 71 are prime number, and each of these columns will have 3 prime numbers each. So 41 is a prime number, and other than 2, no other even numbers cannot be a prime number. So 42 is not a prime number, 43 is a prime number, 73 is also a prime number. See, the starting of these two columns, 41 and 71, they are prime numbers. And the numbers ending with 3. See, this is 73, Keshavananda Bharati. Keshavananda Bharati, or Sachin's birthday year. That is a prime number. Similarly, 43 is a prime number. Now, I told you 3 prime numbers are there in those columns. If you go down, 44 is not, because it is divisible, it's an even number. 45 is divisible by 5. 46 not. 47, yes, 47. India's independence year. That is a prime number. We got 3 on that line. In 70, 71 is a prime number. 73 is a prime number. 75, it is divisible by 5, so it's not a prime number. 77, it is divisible by 7 and 11. We will have 79. Okay, so that is a rule. So I'll just repeat once more. First 8 you have to know yourself. You have to by heart. 2, 3, 5, 7. Then 11, 13, 17, 19. Reference points. Reference point 30, 60, 90. These 3 points are reference points. Before 30 we have 29, 23. After 30 we have 31 and 37. Before 60 we have 59 and 53. After 60 we have 61 and 67. Before 90 we have 89 and 83. After 90, 91 is not there. We have only 97. Then we have the 40s. In 40s we have 41, 43, and independence, that is 47. In 70s we have 71, 73, okay, that is Keshavananda Bharati, and not 77, 79. So these are the prime numbers from 1 to 100. So that's it. So how many prime numbers are there? In the first column we will have 4. In the second column we will have 4. All the green columns, the reference points ones, here we have 2, 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 last we have only 1, and these points we have 3 and 3. So from 1 to 100 we will have 25 prime numbers. Okay, that's it, guys. Thank you. So you can practice this method or revise this.